Hello students, good morning everyone. Good morning students, good morning. Good morning, good morning. Are you getting my voice clearly, Nana? Are you getting my voice clearly? Are you getting my voice clearly? Is the voice audible? Is the voice audible? Right. Okay guys, I hope. Yes, Nana. Yes, thank you guys, thank you. Right, thank you Sanjay, thank you Sangamitra, thank you Sanjay. Okay, Nana, okay. Welcome back everyone to the physics session, and let us go ahead and inform others to join the session quickly. To join the session quickly, inform others to join the session quickly. Yes, let us try to first recollect back the points which I have discussed in the previous session. Before that, let me tell you this weekend portion, the weekend portion. Weekend portion. This weekend portion is from track 1, from collisions. Uh, just a second, guys. Just a second. Let me give you clearly. Yeah. For juniors, collisions, elastic and perfect inelastic one-dimensional collisions. Elastic, elastic, and perfectly inelastic collision. And perfectly inelastic collisions in one dimension, only one dimensional collisions. So oblique collisions are not there for this week. Elastic and perfectly inelastic collisions. So as part of elastic collisions, we have discussed in the previous sessions what are elastic collisions, especially what are collisions, how to classify the collisions based on that, and some few more special cases we will discuss. Okay, right, right. See, coefficient of restitution. Coefficient of restitution. Yes, guys. Still, many have not joined, and try to inform your friends. Try to inform your friends. Right. Yeah. The point here is coefficient of restitution. Coefficient of coefficient of restitution. Coefficient of restitution. E small e. Okay. Small e. In the previous session itself, I have discussed about it. Let us try to recollect this concept back. Let us try to recollect it back. What is coefficient of restitution? Quickly, coefficient of restitution is defined as ratio between relative velocity of separation and relative velocity of approach. It is given as V2 minus V1 divided by U1 minus U2. In vector form, if you want, you can write V2 vector minus V1 vector divided by U1 vector minus U2 vector. So this is coefficient of restitution. It is equal to relative velocity of separation by relative velocity of approach, and the value of E is equal to what? 1 for perfectly elastic collision, and it is equal to 0 for perfectly inelastic collision, and the value of E lies between 0 and 1. So E will be less than 1 and greater than 0, or 0 will be less than E other way. You can say that is E will be varying between 0 and 1 for partially partially elastic or inelastic collision, elastic collision or inelastic collision. So these points you have to remember and you have to keep in mind. And in the previous session we have also discussed briefly about a few points, like what will be velocity of a body of when it is dropped from height, and if it is undergoing bounces on a surface. Okay, after n bounces, what will be the velocity, and what will be the height after n bounces, also we have discussed. So those points also let us try to recollect back once. The the height of, say, that is, if you have a body of mass m, it is released from rest from height h, and if it is striking the ground, so after passing through this and then it will strike the ground and bounces up with a velocity and bounces to a different height h1, then again stops and comes back and again strike the ground. This is after first collision. After a second collision, again it will bounces up to some height h2, like h1 h2 and so on. Okay, so up after nth collision, if the height is hn, what is this? If you want to find, we have discussed this already. This is equal to, the height after nth collision is equal to e power 2n into h. In terms of this, you have to remember this, guys. Sir, coefficient of, there is a question, Sanjay has asked, sir, coefficient of restitution is there for this weekend exam? Yes, obviously. Elastic collision is there, means coefficient of collision, what is that? Elastic and inelastic, whatever it is there means coefficient of restitution should be there. Based on this only, the questions will, based on this also questions will be asked. Okay, here you may say, the questions have classified into elastic and inelastic collisions, and then coefficient of restitution based questions. But here the coefficient of restitution will be involving with these collisions. So this concept also is there. So you have to just cover this part of the collision questions also. Okay. If there is any change, then I will let you know before only, guys. If there is any, by any reason, if this questions from this concept is not going to include, means I will let you know. Okay, but but as per the portion, this also should be there for the weekend exam, right? So this is the height raised by a body after nth collision, whereas velocity after nth bounce, after first bounce, velocity can be taken as v1. Here, before first bounce, the velocity is v. After first collision or first bounce, velocity will be v1. Here, after second collision, it will be v2, etc. So after nth bounce, if you take the velocity as vn, then what is this vn? This also we have discussed in the previous session. Vn is equal to e power n into v, e power n into v. I hope you have remembered this. Go through these points once again, guys. Go through these points once again. Sanjay, is that clear, Nana? Yes, coefficient of restitution based questions also will be there. If there is any change, then I will let you know. Okay. Right. Now, in this session, First, let us try to work out some questions based on this. Then we will discuss few more concepts related to this. So first, let us see the question number. Open your volumes. Let us see the question number. Um, Question number 45. Question number 45. Page number 47. Page number 47. It is given that a tennis ball bounces down a flight of steps, striking each step in turn and rebounds to half of height of the step. The coefficient of restitution is the coefficient of restitution is the coefficient of restitution is. So E is equal to what? Provided if the ball is a plastic ball is bouncing rebounding to half of the height of the step. So that is if initial height, if it is initial height is h1, if a ball is falling through height h, then after first bounce, if it is raising to a height h1 is equal to half of the it is rebounding to half of the height of the step, means initial height. So if initial height is h and h1 is h by 2, then what is coefficient of restitution in this case? So to understand this, we have to use the expression for coefficient of restitution in terms of heights. So what is that relation? We know that E is equal to, by using what you call the definition, relative velocity of separation by relative velocity of approach, we will get a relation called square root of h1 by h, h1 by h, where h1 is h by 2. Directly you can substitute it here. Nothing special is here. So how did you get this? If you remember the what you call the derivation of h relations. So otherwise, if you want, you can write here clearly. But while doing numericals, just you should remember this. But for understanding purpose, let me give you this once. As by definition, as E is equal to V2 minus V1 by U1 minus U2. Here, initial velocity of this is first body. The ground is considered to be the second body. The ground is considered to be the second body. It is said to be at rest initially. So U2 is 0, U1 is, let us say it is striking with velocity V. So this is V. V minus 0 is V, and V2 minus V1. Final velocity of the ground again will be 0, and this will be actually initial velocity will be downwards, so it will be minus V, right? After are you taking with signs? Okay, fine. And V2 here final velocity of the second one will be 0. Final velocity of the first one, if you take it as V1, then it will take it as V1 minus V1. So minus minus gets cancelled, you will get V1 by V. And again velocity of a freely falling body after passing through a height h is nothing but V is equal to square root of 2gh. By remembering this, substitute here square root of 2gh1 by square root of 2gh. So 2g gets cancelled, you get h1 by h. So square root of 2gh1 by 2gh. On simplifying this, you get this one. So that is how you will get. Okay, because of this. Okay, you have to recollect, you have to remember this step. Now here, h1 is h by 2. So you can write it as h by 2 by h. On simplifying this further, you get 1 by root 2. So this implies, therefore, E is equal to 1 by root 2. That's it. Very simple. So which option is right? 1 by root 2 is second option. That's it, guys. Next, question number 46. Question number 46. What is given here? Let us see. A ball hits the ground and loses 20% of its momentum. Then coefficient of restitution is. A ball hits the ground. A ball hits the ground means is falling and hitting the ground and loses 20% of its momentum. Means let us say initial momentum P1 is equal to P. Then after hitting, the final momentum, let us say it is P2. After hitting and when it is bouncing, P2 is equal to what? P2 after what is that? After it hits the ball hits the ground, it loses 20%. So what will be the remaining one then? As it loses 20%, remaining will be 80%. 80% of initial one means 80%. 80% means 80 by 100 times the initial one. You can take it as 0, 0 cancel, it will become 0.8. 0.8p. P2 will be 0.8p. That is the given thing. Then what should be? If P1 is equal to P, P2 is equal to 0.8p, then what will be coefficient of restitution is the question. How to find this? We know from definition, we know that coefficient of restitution is relative velocity of separation divided by relative velocity of approach. Relative velocity of approach. So, but given momentum of before bouncing and after bouncing, initial and after, or you can say the relative momentum after bouncing and before bouncing, or while striking. So, if velocities, if you multiply with the same, body is same, so mass will be same. If you multiply both numerator and denominator with the m, what will you get? Relative velocities into mass gives you relative momentum of separation by relative momentum of approach. Can you write like this? Relative momentum of separation by relative momentum of approach. Right? This can also be expressed as rebound momentum by striking momentum. So relative momentum of separation. Relative momentum of separation by relative momentum of approach. So this can also be expressed as rebound momentum divided by striking momentum. Striking momentum. Approach means striking part during the striking collision part. So this is nothing but E. A rebound momentum means with what momentum it is rebounding, with what momentum it is moving up. What is that? P2 momentum. P2, that is 0.8p, or you can write first P2 by P2 is the rebound momentum. Rebound momentum is what? P2, and striking momentum is P1. P2 is 0.8p and P1 is P. So we'll get 0.8. So did you understand how to get this? Therefore E is equal to 0.8. So this is how we will get this one. So which option is right? Fourth option. That's it. I hope it is clear for you guys. Next question. Have you copied this, everyone? Do it fast. Next. Right, next. Next question. Let us see. Yeah. You see, there is another question. That is, actually the next question is based on time taken. So we need to discuss the related concept, guys. So to work out these questions 47 and 48, we need to just have a brief discussion about two simple concepts. So let us see those first. So the question is actually, it is given that a plastic ball falling from a height of 4.9 meter rebounds number of times. If the total time for the second collision is 2.4 seconds, then coefficient of restitution is in terms of time. Time in terms of E or E in terms of time you want. So to understand that, let us consider another subheading here. Write down here, everyone. Write down another subheading. Not a question. Write down this. What is this is? To find total time taken by a ball to stop bouncing. Write down subheading. To find total time. To find total time taken by a ball. To find total time taken by a ball to stop bouncing. To stop bouncing. What does this mean? Let us see. What does it mean? Let us see clearly. So, to understand this, let us again redraw the diagram which we have considered in the previous cases. Let us consider there is a body of mass m which is under free fall. If you drop it with initial velocity 0, when it is falling through a height h, then after just before hitting the ground, after passing through this height, before hitting the ground, let us say its velocity is v. Then after the first collision, it bounces. So it bounces up. It bounces up with velocity v1, and it goes to some height. It goes to some height h1. It goes to some height h1, and it takes time t1 to go through this height. Then it stops again because it is moving under gravity. It stops after going through some maximum height. This h1 will be less than h. Then it again retraces back and it travels this distance, and before hitting the ground it will obtain the same velocity as that of v1 after traveling to the same height h1, and it takes same time t1 to pass from here to here. To travel from here to here, it takes time t1, the same amount of time it takes it will to travel from here to here also. Are you following this point? Same way. Next, after coming to the near to the ground, it undergoes a second collision. So after second collision, it bounces up with some velocity v2. Then again with this velocity, it goes to quickly. Respond quickly now. Right. Okay. So listen here. When you to understand this, you have to remember the freely falling motion. Otherwise, you will confuse here. You will not understand anything. If you remember freely falling motion case, if you just drop your body from rest from height h, right? The velocity obtained by before it hits the ground is v. After passing through this, what is that height h? And let us say to travel this height h, it takes time t. It takes time t, and you should remember these expressions from the concept of really falling motion. So already we have discussed some of the relations here. You can say the velocity v is equal to square root of 2gh. After passing through this height, velocity obtained is v equal to root 2gh. Alright, and by using one of the equations of motion here, that is s is equal to ut plus half at square. If its initial velocity is 0, this term will become 0. If it passes through a distance called distance equal to h, if s is equal to h, then to travel this distance with the acceleration due to gravity g, then it takes time t. Then it can be expressed as 0 plus half gt square. Here it will be minus this also, g also will be equal to minus g, minus gets cancelled, then you will get this one. So from this, if you will get t is equal to, on cross multiplying, 2h by g is t square, and hence t is equal to square root of 2h by g. You will get this time to travel from to travel through a height h. So this is this point you have to remember here. Now the point is to find total time taken by the ball to stop bouncing. First, to come here, it takes time t. Then after first bounce, before second bounce, it goes to maximum height, and it takes time t1 for this. Again comes down, it takes time t1 for again to come down. That means it takes 2t1 plus t1 2t1 before striking or before second bounce. After second bounce, it takes t2 to go up, again t2 to come down. So 2t2 to come down, undergo third bounce. Like that, it takes the time intervals in every bounce. So we can say the total time taken is, first time taken to come down from the height is t. If you take it as t, plus to go from here to here and back to here is 2t1 plus, and again to go from here to here and back again to here is a 2t2, 2t2 plus so on, infinite number of times it will bounce us like this. Okay, infinite number of times. So here, as a t is equal to 2h by, here I can write where t is equal to square root of 2h by g. You should remember this. For remembering purpose, I have given you this. You have to remember this. Okay, t equal to h by g. And what about t1? And t1 is equal to, when it passes through a height h1, it will be equal to 2 h1 by g. Here, otherwise just let us write here, and let us try to write this in a different way. So and t is this, so t1 is equal to square root of 2 h1 by g. Time taken to travel h1 is h1 height up or down will be same time, it is equal under gravity, so it is equal to 2 h1 by g. But h1, you should remember that v is equal to this, already I have discussed in the while recollecting. H after first of nth collision or nth bounce is e power to h to e power 2n into h. After first bounce e power 2h. So after second bounce e power 2 into 2 e power 4h, like that it will we have to write the expression for h. So after first bounce, h1 is, where h1 is, you can say here, because h1 is equal to e power 2 into h. So if you substitute this here, e square h or e power 2h, this can be further expressed as square root of 2 into h is e square h. h1 is e square h by g. This everything should be under root. Okay, so this is t1. Similarly, t2 will be, t2 is equal to square root of 2h2 by g, where h2 is e power 2 times the previous height, or in terms of h if you want, after second bounce if you want, you have to take in the general expression, height traveled height after n bounces is equal to e power 2n into h. After first bounce, e power 2 into 1 e power 2h. After second bounce, e power 2 into 2 e power 4h. So this you can express it as 2 into e power 4h by g is t2. So here in this t2, h2 can be expressed from this. You have to remember this relations, guys. Now if you substitute this in the final expression of capital T, you can write it as capital T is equal to T is what? Square root of 2h by g plus 2e into t1. T1 is this, 2 into square root of 2e square h by g plus 2 into t2. T2 is this one, square root of 2 into e power 4h by g plus so on up to infinity. Here if you observe, in all this first expression is different. In all these expressions, 2h by g is common, and e square is here, e power 4 is there. This can be expressed as e square into e square. So 2 e square h by g is common in every term. That is what you have to understand. And based on by separating this out, how can you write? Let us see. E square is common, right? This e square also, if you take it out, e square in every term, if you take it out, e square comes out of the root, it becomes e. So then you can write this as square root of 2h by g plus, if e comes out, it can be expressed as 2e into, if e comes out, it becomes 2h by g only, right? So into 2h by g under root plus 2 into, if one e square comes here, this becomes e, then one e square comes, another e square will be there. So 2 e square h by g plus again 2e into e power 4h by g, so on h. In these terms, try to write down simultaneously, guys. Try to write down these steps. And if you have any confusions, just drop me a message in the chat box, in the live chat. right? This will be equal to here square root of 2h by g. Let us write this as it is, first term. In second term and all, here 2e is common in every term, and 2h by g, 2h by g, under root 2h by g is also common. So this if you take especially 2e into square root of 2h by g also, if you take out, if you take this out, what remains here? 1 plus here, if you take 2e out, 2h by g out, square root of e square will be there, square root of e square will be e, plus the next term square root of e power 4 will be there, that will become e square. Like this kind of terms will get up to infinity. It is a sum of infinite terms. Sum of infinite terms will get. This on simplifying further, you can write it as square root of 2h by g plus again you can write like this, 2h by g, here 2h by root square root of 2h by g is there common, right? This also let us take it out, then you will get 1 is there, plus this 2e is there, right? Yeah, 2e into this is sum of infinite terms. Here you should remember one more relation, one more formula. If sum of infinite terms, if you are having like a plus ar plus ar square plus so on up to infinity, sum of infinite terms, if a is first term and r is common ratio, that is ar by a is r, ar square by ar is r, so common ratio is r, then the sum of infinite terms can be expressed as first term a divided by 1 minus r. This also you have to remember, guys. This relation will use in different other chapters also, sum of infinite terms condition. Okay, by making use of this, we can write it as 2e into this has gone out, this will become, first term here is 1 and common ratio is e by 1 is e square by e is e, that is called common ratio r. So you can write it as sorry, how can you write this? First term by, first term is what? 1 divided by 1 minus common ratio is e. This is how we can write, and one more bracket here to close this. This further, on simplifying further, you can write square root of 2h by g into 1 plus 2e by 1 plus e. It is 1 plus 2e by 1 minus e. This on simplifying by cross multiply, if you cross multiply this, it becomes 1 into 1 minus e is 1 minus e plus 2e by 1 minus e. This can be expressed as it is equal to square root of 2h by g into let us write here. I hope you guys are copying simultaneously. This can be expressed as square root of 2h by g into 1 minus e plus 2e divided by 1 minus e. This on simplifying further, 1 minus e plus 2e is 1 plus e. So 1 plus e by 1 minus e. So this will be the total what? Total time taken before stopping, total time taken by the ball to stop bouncing, this much time it takes. So t is equal to square root of 2h by g into 1 plus e by 1 minus e. So this will be the total time taken to stop bouncing, completely to stop bouncing. Okay, note it down fast quickly. Before going ahead with the next question, let me give you one more what do you call application here, additional point. Then we'll go to the related questions. Next, write down here one more subheading: how to find the total distance traveled by this ball before it stops bouncing. Means before, to stop bouncing, it takes this much time. In this much time, how much distance it travels? How much distance it travels is the question. So see here. So write down next subheading: to find what? Total distance traveled by a ball. To find total total distance traveled by a ball, to find the total distance traveled by a ball before it stops. Before it stops. To find total distance traveled by a ball before it stops. How can you find this total distance? Let us see now. To find total distance traveled by a ball before it stops. Before it stops. Right. The pictorial representation you have to use for this also. What is this? This picture, this diagram you have to draw. This diagram only you have to take, guys. This diagram only, let us take once again, because understanding the diagram is also important. Yes, Sanjay, I hope you now you have understand the diagram. If you understand the diagram, the steps will be clear, guys. Okay, every others also try to understand this diagram clearly. Then you can understand the steps so easily. So if a body of mass m is released from height h with initial velocity 0, okay, before striking the ground here, it has traveled a distance of h. Then after first collision or after first bounce, it here before striking it was obtaining a velocity v. Now after first bounce or collision, it bounces up with velocity v1, and with this it raises to some height h1. It raises to some height h1 in time t1. In time t1. So after reaching this maximum height, again it behaves as a freely falling body. It stops and then it retraces back and it travels the same distance h1 to strike the ground. So after before second collision, it will travel height h1 and back h1. 2h1 distance in this part it will travel. So then after second collision, it will bounce up with velocity v2 and travel to some different height h2, then it stops, again travel the same distance h2 down. So that means 2h2 it travels down before third collision. Are you following these points, everyone? So it first travels a distance h before first collision. After first collision, it travels a distance of h1 plus h1, 2h1. Then after the second collision, it travels a distance of h2 plus h2, 2h2. Likewise, before stopping, it travels the distance, total distance, total distance traveled, can be given as d is equal to distance traveled before first collision is h only, h plus before first collision. Before second collision, h1 plus h1, 2h1. And before third collision, before third collision, it travels h2 plus h2, 2h2, 2h2. Likewise, next, again here it will travel to a height of h3, then again comes back the same by traveling to the same distance before fourth collision, right? It will travels 2h3 h3 plus h3 2h3. Likewise, it travels infinite number of times this kind of two distance heights. I hope this is clear for you guys. Next, to find this in terms of coefficient of restitution, we should recollect back what is this h, h1, h2 and so on, where h is equal to what? H is equal to what? We want in terms of h only, so no need to take h is equal to, h1 is equal to, where h1 is equal to, where h1 is equal to, already we have discussed, hn is equal to distance after nth collision. Height of nth collision is e power what? E power 2n into h, right? After first collision, e power 2 into h. After second collision, e power 2 into 2, e power 4 into h. After third collision, e power 6 into h. Like that you have to take directly. So h1 is equal to e power 2h and h2 is equal to e power 4h, h3 is equal to e power 6h. In terms of h only, we are taking all. So if you substitute all this here, then because of this, because of this, or by using this substitute. Then we'll get D, total distance D is equal to, total distance D is equal to, H is, let us take it as it is, H plus H2 into H1 will be E square H, E square H plus 2 into H2 will be E power 4H plus 2 into H3 will be E power 6H plus so on up to infinite terms, infinite terms. Then in every term, of course H is constant, but this is a special term H, let us keep this as it is, and in these terms 2 e square h 2 e square h into e square 2 e square h into e power 4. So you can write like this. So in every term from here onwards 2 e square h will be common, 2 e square h will be common. So in all these terms if you take 2 e square h common, then here we get 1 plus here we get e square plus here if you take e square out we get e power 4, e power 4 plus so on up to infinite terms. I hope it is clear for you guys. Okay, next this again, to simplify this part we have to use sum of infinite terms. Write down this formula again, once again write down every part and every write down everyone, every step write down clearly. S, if S infinity equal to A plus AR square plus up to infinite terms we are having, sum of infinite terms can be expressed as, if this is first term, this is common ratio, then you can write it as A by 1 minus R, a sum of infinite terms, provided if common ratio is less than 1. If it is greater than 1, I have to take it as R minus 1. That is also important. Okay, now we are taking because R is common ratio is less than 1 case only. Now by making use of this here, you can write this is equal to H plus 2e square H into, first term here is 1 divided by 1 minus common ratio, e square by 1 is e square, e power 4 by e square is e square, common ratio is e square here, e square. So this is common ratio. Now this further simplifying, you can write it as this is equal to H plus 2 e square H divided by 1 minus e square. Here H is common in both the terms. If we take this out, what do you get? H into 1 plus H we have taken out, this becomes 2e square. 2e square by 1 minus e square. This you simplify further, you get 1 plus H into 1 minus, not 1 plus. Here 1 minus e square, here 1 minus e square plus 2e square plus 2e square divided by 1 minus e square. So here 1 minus e square plus 2e square becomes 1 plus e square. This further can be expressed as, therefore total distance traveled is d is equal to h into 1 plus e square by 1 minus e square. So this is how we get the total distance. By making use of these relations, the above relation, the total time taken for the body to stop, this is the total distance traveled before the body stops. We will work out few more questions. Now let us see the question number 47. Open the page number 47 again. Open the page number 47 again. Question number 47. Page number 47 only. So what is given here? A plastic ball falling from a height. A plastic ball falling from height h. H is equal to 4.9 meters. It rebounds number of times. If total time for second collision, so it undergoes first collision. After first collision, it rises to height h1. Next, it comes back again through h1, then undergoes second collision. So the point here is, if total time for second collision, before second collision, time taken, let us say this is time taken to come down, here is t, and here it has taken t1 time to go up, again t1 time to come down. So 2t1 if we take, then coefficient of restitution is, that means you have to take the total time till second collision, means total time is equal to time to come down is t before first collision, after first collision 2t1, before second, that is after first collision or before second collision. Before first collision t, before second collision 2t1, before second collision 2t1. This is the total time taken. This is given as how much? 2.4 seconds. 2.4 seconds. Then what is coefficient of restitution is the question. Very simple, guys. Very simple. Follow this carefully. So we know that. What is that? 2.4 is actually here we know t in terms of height. That's what I have to write down here. We know that t is equal to what? T is equal to, already have copied here, T's. T's. T is equal to what? Square root of 2h by g. T is equal to square root of 2h by g. T is equal to square root of 2h by g and 2h by g, and t1 is equal to square root of 2h1 by g, where h1 is e square h, that is equal to e square h by g under a root, or you can write by taking this e out, e into square root of 2h by g. This is t1. So if you substitute t and t1 here, you get t, capital T, which is equal to t plus 2 t1. So where t is 2.4, which is equal to t will be square root of 2h by g plus 2 into t1 is e into square root of 2h by g. Got it? So this 2h by square root of 2h by g is common here. So this further can be expressed as in one line only, I will write square root of 2h by g. If we take out, then it becomes 1. 1 plus 2e is equal to 2.4. Is equal to 2.4. You are asked to find e. So let us keep this term here and let us rewrite this as, this implies 1 plus 2e is equal to, this is equal to 2.4 by this. 2.4 divided by square root of 2h by g. So this is 1 plus 2e. So 2e you want, so to keep this and send this here, then you can write it as 2e is equal to 2.4 by 2h by g under root minus e. So e you want, again divide this, substitute these values. This is 2.4 guys. This is h. H value is 4.9. If we take it as g as 9.8, then it becomes what? 4.9 2 to this gets cancelled, you get 1. So 2.4 minus 1 will be equal to 1.4. So 2e is 1.4. 2e is 1.4. So e will be, on simplifying this, we will get e is equal to 0.7. That's it. That's it. Simple. So option 3. This is how you will get. This is how you will get. Okay. This part is 1.4. So 2e. What is this? 2e is 1.4. E is 0.7. Okay, like this, you can try question number 48 also. This from here onwards we will continue in the next session, guys, and we will work out as many questions also as possible along with the proper concepts and applications. As time up, I am winding the session now. It's okay. Go through, and if you have any questions or confusions, you can get back to me, guys, at any time. Okay, take care, everyone. Bye bye.